Welcome to VINDAL'S concepts once again. This question for number 4A, we're going to be looking at it. The first question there talks about optical center. We say we should draw a convex lens to represent an optical center. This is a converging lens, or we call it convex lens, and it has a principal axis given as a line drawn. And this principal axis will enter into this glass, into this lens, and it will not deviate. It will just enter like this without deviating. So remember that the concept through which this was driven is a refraction. And for a refraction has to do with the bending or deviation of light as it enters from one medium to the other. This medium is air, while this medium inside this place is a glass. Imagine that there's a glass inside here. So when a path of light or a ray of light enters in here, it will deviate in one direction. So that is what about this. So as you can see, what is optical center is the point on a lens through rays of light, through which rays of light pass without deviation. So this line will enter here without deviation. I hope you understand that. The next one talks about another convex lens too, whereby we have this place as principal focus, and then this line entering this convex lens is called principal axis. And remember, it doesn't deviate. And when a light ray passes through this principal focus, it enters inside this glass, which is a lens, and it comes out parallel to this principal axis. What I mean by parallel is that the line through this will be traveling will not meet with the line through which this one is traveling. Therefore, we say that the lines will be parallel. These lines we are showing here all represent the path of light. The path traveled by a light is all these lines that we draw, what we have written. And this is a convex lens. This convex lens can just be, is an example of lens we use in. Still, this number 4B, when the light is parallel and they enter into this convex lens, they will not diverge, they rather converge at this point called principal focus. They will converge at this point called principal focus. It will enter here and go this point. This one will also enter into the glass, deviate to this point, and they will all converge at this point. Okay, this one is a concave lens, and a concave lens has a principal focus which is different from that of a convex lens principal focus. And the principal focus of a concave lens is defined as the point on the principal axis where all the rays close and parallel to this principal axis appear to diverge after refraction. That is this point, which is called the principal focus of a concave lens or a diverging lens. Now, let's look at the principal focus of a concave lens. This is the principal focus of a concave lens, a convex lens, This is the principal focus of a convex lens or a converging lens, which is defined as the point on this principal axis where all the rays parallel and close to this same principal axis appear to converge after refraction. Thank you. Okay, this is the question, the solution to number 4. This formula is given here, mirror's formula or lens formula, and U is the distance from the object to the lens, while V is given as the distance from the lens to the object. U was given as 105, and then the next thing they gave us was magnification, which is given as m equal to 4. Magnification does not have any unit, okay? But recall that magnification is given at the distance of the image from lens, all divided by distance of the object from the lens. Now, since you know that m is given as 4, we have 4 equal to V over U, and V means 4 multiplied by U. Then On a proper arithmetics, you realize that the LCM, this is supposed to be V, but I replaced this V as 4 multiplied by U. Then taking LCM of FU and 4U, I have LCM as F4FU. When you multiply the LCM with all the individual fractions that make up this, that's another way, very good way of clearing fraction. Then you have this. Remember the cancel. I cancel F, I'll cancel F here. Then I have FU left. This is FU. If I cancel U here, I'll cancel U here. I have 4F. And I also go here and cancel 4U and cancel U and cancel 4. I have only F. So then remember that this U is giving us 105. So 4 multiplied by 105 is 520, is 420. And then 4F plus 1F is giving you 5F. Then when you divide both sides by 5, you have that the focal length F is giving us 84 centimeters.